Okay. Sound. Looks like we have sound. Slightly. And I think ready to go. Let's take okay. Jumping right into it, basically just picking up where I left off with this little cat animation. Now it's scratching its paw, cleaning its head a little bit, and run around and stuff as well. You can check out the previous video if you want kind of the overview on this thing. So today I want to basically take some of the stuff that's currently happening inside Animate and move it to Update. Update's going to be more like cat behaviors, deciding when to stop and sleep, scratch its head, versus just keep going, run into the edge, and scratch it. Right now, a lot of this logic lives inside of Animate. Really, I think only want this stuff. All of this kind of logic. A hotkey thing. Back around a little bit. Be able to use the hotkey. This kind of logic should live inside of here, and it should, I guess, animate first. And I think right now, yeah, I just hard-coded it to change to cleaning, which is just for testing. We don't really need this or this. So just to make sure, yeah. Oh, that's not what I expected. Should we start with just sitting? Are we not sitting? Current state sitting. Oh, well, but we still have all of this logic, which is changing us, I guess, right? Okay. So I'm gonna... There was a multi-line comment. You're down there when I seen him. Okay. So that's closer to what I expected, but no, still not quite right. So we're running down and to the left, but, well, down and to the right. But why? Oh, well, that would do it, wouldn't it? Okay. Okay. Trying to just get back to level set sitting only, doing nothing. There we go. So we want to know what time it is. I may want to know what time. I guess we don't need to just yet. So we need to know whether, broadly speaking, which states are moving states and which states are non-moving states. I think what I'll do is after we declare all of these states, let's go moving states is a list. And can I just include all of these things in it? I like it. I guess it could be a tuple. I'm trying to, I don't know if it actually matters, but I'm trying to be mindful about using a tuple when I don't need to add things to it or modify the things inside of it. Seems like it should save a little memory, but I'm not actually sure if it does. Might be handled under the hood. I don't actually know. So moving states, non-moving states. Because if we're currently in a moving state, then we will choose a random number basically, and if it's a certain, a certain percentage of the time will change to a non-moving state. So we need to know which states are moving, which states are non-moving. So specifically, non-moving is cleaning and sleeping, and I guess sitting as well. Scratching states are an interesting one. They would be considered non-moving, but I don't think I really want to just stop in the middle of a movement and start scratching. I think I want to always scratch the edge of the screen. So we'll always get to a scratching state by running into the edge, not by just randomly choosing. Therefore, I don't think we want them in the non-moving states. So does this actually work? Can I say, like, this is going to print a lot, but that's fine. Can I say something like print, what is the current state? Current state in these should probably be, I don't know, static or constants or something where they don't need the class, the object instance in front of it, but this will print if the current state is in the non-moving states, which right now we're sitting, so it should be true. And just to make sure this is actually doing what I think, I'm going to check this one should be false. Okay. Perfect. So this is how we can know whether we're currently in a moving state or a non-moving state. I'm going to go ahead and save it so it stops spamming the prints. I think... what do we do to get a random? Rand int or rand range. Oh, it's inclusive on both sides. Okay. Okay. Did we got ones? Yeah, we got ones. Okay. So we kind of want to hit a sweet spot of like sometimes the cat will decide to stop instead of going all the way to the edge, but other times it will decide to keep going and make it to the edge. But the chances get kind of convoluted because it's taking steps that are movement step sized, which is I think 10 right now. 10 pixels. I'm running it on a PyPortal, which is 320 by 240. So we have about 32 steps horizontally that it can take, except there are a few less because our sprite is 32 by 32 as well. So it's maybe 8 or something, 7 or 8 steps, really. No. Down from 32, so it'd be more like 20 something, 20, I don't know, 25, 27, 28. So what if we say, so like, it's gonna take us about that many steps. If we're going horizontally, it'd be more diagonally, I think. So why don't we say, let's start with like a 1 in 30 chance that we stop. So inside of update, if we're currently moving, this should not be Neko though, right? This should be self. I should have done self here, self. Self.current state in. Maybe I should make a moving property that actually does this. That way the code is like self-documenting sort of def moving. Is moving? Should we go is moving? It's moving. I kind of like is moving. Self property return. So it's going to return true if we are moving, so return self.current state in self.moving states. Because now this code can say if self.is moving, so it's like describing more so what the code does now. It's nice, it makes it easier to understand, I think. So if we're moving, then there's a 1 in something chance. You know what I'll do is I'll go ahead and make a config for it. Config chance, stop chance maybe? Stop chance. But what is it really? Stop chance, would it be 30 or stop chance factor? Factor? So it'd actually be 1 in 31, wouldn't it? Because we just saw that rand int is inclusive. Could subtract 1, I guess. So I'm gonna call this roll, like as if we rolled a dice, kind of. Roll is random.rand int 0. Can we pass just 1? That's alright. Let's go 0 config this. I'm gonna -1. That way we go 0 to 29. we'll need to import that. If roll equals, what's the lucky number? We just want to call it 0. We're moving, we hit our chance, we're gonna stop. So we want to choose, let's choose a random one of the stopped states, or do we want to, I almost think we don't want to go to sitting, truthfully. We have sitting in the non-moving states. I almost think we want to keep it going, right? It's kind of an animation example. Sitting is the only one where there's not actually really an animation. It's just the cat sprite doesn't change at all. So let's go chosen state equals random choice from state cleaning and state sleeping. What's the typo? Space? No. No. Got the help with channel up over there as well. So we choose our state, and then I think we just go self current state equals chosen state. So now if we are moving, we should have a chance to stop. So some of this stuff we'll need still, so this is basically okay. So if we're moving, which we already have this actually, so maybe we break, or is there a way to need to check if we're moving? I guess we don't really need to check if we're moving because this is doing movement step, which will be 0 for the ones where we are not moving. We don't really care if this executes. I need to add this to the stubs, or it is added to the stubs, but I just don't have the newest ones. So basically, if it's allowed to move to the right, then we take the step to the right. Or left actually. If it's allowed to move horizontally. Basically, if it's not touching a wall in the direction that it's moving. And this would change the state before we get to here, so if the state changes to one where it doesn't move, then the new movement steps will be 0. So then this will not cause it to move after we change. So else we ran into the wall. But we do need to know which wall we ran into, which is where this came in. we ran into specifically a side wall. We don't know if it's left or right yet, but it's one of the side walls. Then this if statement here is what tells us which one. So if x is greater than config step size, that means that we did not run into the left side wall. So ran into right wall, and then else down here would be ran into left wall. Maybe I'll put these inside. I think I like them inside a little better. So I think no matter which wall we run into, I think I want to scratch it. So if we ran into the right wall, we should set the state to scratching right. If we ran into the left wall, then we'll set the state to scratching left. We're going to have similar logic for the up-down movement. So if we're allowed to take a step in the vertical orientation, up and down, essentially we're not touching the top or bottom walls, then we will go ahead and take the step. Else, here we ran into either the top or bottom wall. Ran into top or bottom wall. And we do this same kind of thing here, but it's going to be on Y. And this would be the bottom, because Y gets bigger as it goes down. Ran into bottom wall. And we want to set the state, current state, scratching down. Ran into top wall. We will scratch up. Okay. So now we need a way to, basically while we're in a non-moving state, we need to wait for a few seconds and then go to a moving state. So that's going to be, I think, else here. So we're in a non-moving state. But one problem is that scratching states are not... Okay, but the scratching states are not in the moving states, so the scratching states will return false for is moving. Would go to here. I guess we can just use the same kind of mechanism. Let's just roll. This way the cat will pause for seemingly random, like it will scratch for a random amount of time. It won't like always scratch for exactly the same amount of time. Yeah, I think I like that. But we will have a smaller chance, I think. We don't want to wait. I guess we'll just play with it and see how long of a factor it ends up being. Of course, this gives it the chance to... This gives it the chance to stop moving immediately. Stop scratching immediately, which actually I don't think I want that. I think I want... It always last at least a certain amount of time. minimum stop time. Let's say 2 seconds? 3 seconds? We're gonna also make a last state change time. So now when we change states, we'll update this. And then in here, we'll say current time if now minus, no, I'm gonna do this differently. Actually, if now is greater than, less than, or equal to last state change time plus minimum stop time. But when we change, this gets updated to now, this gets added to it, so 2 seconds more. We wait until now is then less than that. It means we have passed that amount of time. Yeah. Minimum stop time has elapsed. Okay. Then we'll choose, let's say, to make another one of these, and I don't know, I think it should be more likely than the stop chance. So let's call it N and see how that looks. Oh. Wait, what? Right. Stop. Config. So it would be start chance factor, right? Start moving. This is kind of config stop, and the stop means to stop moving. Start chance factor. Probably be nicer if those had moving in the name, but then they would be quite long. Maybe I should drop config. Don't know. Start chance factor minus, we'll do -1 again. Roll if, roll 0 again. Then we want to choose a direction and start moving. So choose from all the direction. New state equals, oh, we did chosen state. Let's keep that. States. Current state equals chosen state. So one thing is this doesn't restrict it from trying to move direction it's at, right? We could be not moving, we could be in the state scratching the left wall, which means we're next to the left wall. This could then choose to move left or up and left or down and left. Which means we would then get into here, not be allowed to move. Therefore, go back to scratching left. Therefore, we get another 2 seconds of scratching left. And then make another chance to start moving, and then choose a new direction again. So I don't think it will break it, but it could make it stay doing the wall scratching for a longer period. But I do kind of want some randomness in this, so I don't think that's entirely a bad thing. So let's just walk through the logic we have now, and if it seems okay, then we'll run it. So if we are moving, make a random roll, and if we hit our roll, then we're gonna choose to stop moving and either start cleaning or sleeping. Update the current state. Okay, that part seems fine. If we were not moving, if we have been not moving long enough, we have a minimum period that we want to stay stopped. If that's elapsed, make a roll. If we hit our roll, choose a new state from the moving states and set it. And then out here, this happens every time regardless of what happened above. So if we're allowed to move horizontally based on the movement step size of the current state, then go ahead and take the step in the current direction. If the step size was 0, technically we're going to take a 0 size step, but it's not going to change anything. If we're not allowed to move horizontally, figure out whether we are touching the right wall or the left wall and set it to scratching right or left accordingly. And again, this is going to be happening regardless of anything above. This will always happen. Check if we're allowed to take a step up, in the vertical orientation, up and down, based on the movement size of the current state. Again, if it's 0, it's going to take the step, but it won't actually move. We're not allowed to take a step because we're touching a wall. Figure out which wall. Oops. So this says ran into the bottom wall, and then this says, oh no, that's right. Yeah, scratching down. Ran into the top wall, scratching up. So this should get us back out of the scratching state. Should also get us out of the cleaning and the sleeping states. And running into a wall should put us into the scratching state. That sounds good to me. So let's do this. Am I on top of that? Only in the corner. Move myself a little lower. Do that for now. So gonna tweak the focus. I feel like we can get slightly better, can we? Yeah, a little bit, I think. Okay, save this. Run it. Oh. Much too fast. Does look random though. Hmm. Right. So we only want to move on frames that we did animate. So I think here we want to return true, and here we want to return false. So basically, if we did actually animate based on the time, then we return true. Otherwise, we return false because nothing happened. And then in here, we say did animate equals this. And then here we should do basically only if did animate, then we do all of this. Because we only really want to do movement things on frames that we also animated. Oh, okay. We scratched the left wall, then we are running to the right, we stopped, we're cleaning. Okay, we're running down. We hit the wall, we're scratching the wall, we're running up and left, stop to sleep. Oh. We took off awfully quick from sleeping. So I think we need to handle it differently for sleeping and cleaning. Because on sleeping and cleaning, we do not want to just randomly leave, actually. What we want to do is, once we get to the end of the animation, then we want to choose a new state, right? These ones have these long animations for sleeping and cleaning. Okay, so I think here we only want to do this if self.currentState animation list, or we have like, yeah, underscore, okay, animation list. If the length of the animation list is less than or equal to 2, then we want to do all of this. It's going to be, that's essentially every state that's not sleeping and cleaning. All the moving states are 2. All the scratching states are 2. Sitting, of course, is just 1. Sleeping and cleaning are the 2 states that do have longer animation lists, but I'm going to make my if statement this way in case if we add other states in the future, then this would also catch those. So broadly speaking, anytime we have more than 2 animation steps, we want to run through all of them. So else, if that was not true, that means we do have more than 2. And in that case, we want to not randomly move on, but just move on if we have played the last one. Current animation index is going to be what we're going to check. And this is all happening after we animated. So when a state first begins, we would be on current animation index 0. We would call animate. We'd call advance. This would end up putting it up to 1, and then 2, and then 3, and then 4, and so on until it gets to the last one, at which point it would wrap back around to 0. So after we get done with animate, once we get back from animate, if the index is 0, then we know that we played the full animation. Current index, if it is 0, we know that we played the full animation. So then we go, yeah, we can do the same. Do this still, just choose a random direction and start moving. But we don't worry about the roll, we're just always gonna go after we've done playing that animation. All right, running down, stopping, cleaning. Up and left, scratching the top. Left, scratching in the left. Down. Up. It finished scratching pretty quick there. Get to the bottom. It looked like we made it to the top, but we actually stopped and slept instead of scratching. I think I'm liking this. This definitely feels very random. I feel like it, when it's leaving the scratching state, I didn't see it that time. I feel like sometimes when it leaves the scratching state, it takes the first step while the sprite still looks like scratching. I feel like it did it there after sleeping as well. We got scratching up and then scratching right. I wonder if sleeping should be just a little bit longer. Maybe give it 1 or 2 more frames of the Z's. I'm liking the feel of this. Definitely feels like we got a good mix of stopping before we get to the edge in order to sleep and clean versus actually getting to the edge and scratching. It's the danger in a project like this. You could sit and stare at it for way too long. So sometimes we don't always stop in the same place on the walls. I think we should change it to where, yeah, so like now we're scratching further away. Sometimes it's scratching like right up on the wall. I think we want to be like 1 pixel away. I think maybe we should add a little bit more sitting also at the end of, honestly, at the end of both of these. I think there should be a couple more frames of sitting. I also want to do something to always be closer to the edges. Like here, it's pretty far off. The top edge it's touching in this case. There we saw that. Like it looked like the first step it took, it was still in the scratching. Bottom is not touching. Yeah, I feel like we're taking our first step and we have the wrong sprite showing. So let's walk through the logic. We only update the sprite inside of animate, right? This is the only place we have this, yeah. So, and then yeah, okay, so what's happening is let's say we're at the end of scratching. We called animate. We did animate. We're not moving, so we're not moving, so we get a chance to start moving. When we hit our chance, we update our state to the moving state, Once we get to here, we take our step, but we have not called animate again yet, which means we're still showing whatever the previous sprite was. So I think when we change states, we should also update sprite that's showing. Could just lift this from animate, right? It's going to be the same logic, I think. Or should we just call animate? But then we have the whole time thing. It might not be time to animate yet. Set the new state, set the new animation, set the index to 0, change the sprite that's showing to the first sprite in the current animation. So now whenever we choose to start moving again, we'll update the sprite for the first time. We have kind of an unnaturally long pause there at the beginning. Maybe we should make a special case for sitting. Sitting should be more likely that you take off than the other non-moving states. That was interesting. We kind of moved to the left slightly. Okay, sleeping. I do want some more Z's in the sleeping. I think it should be asleep longer, so I think this is like sitting, yawning, sitting, yawning. I think these are the Z's. So let's do a couple more sets of them. And I think also here, once we know we're at a wall, I want to go self.x equals self.display size 0 minus self.tile width minus 1. Yeah. I think I want it like 1 pixel away from the right edge. And then honestly, I want it 1 pixel away from each edge. And right now, it's just stopping because it got close enough. It's within the step size, but it might be 1 pixel, it might be 5 pixels, it could be anything from 0 to 10. Then we just hard code it back to being exactly 1. So in this case, when we're on the left wall, we're just setting it to 1. We don't have the width to care about. So top and bottom, when we run into the bottom wall, this one is more like the first one, self.y equals self.display size 1 minus self.tile width, tile height, we should use false y equals 1. I think this will make it so we're always stopping exactly 1 pixel away from the wall. Yeah, it looks like we got our 1 pixel from the top there. Let's let it run for a little while and watch it as it hits the edges. Up and sleep. Got some extra Z's this time. Yeah, that feels better. Ooh, scratch. We moved away so fast. Why we moved away so fast? Black Kitty. He's in the backyard. Oh. We're not stopping for the minimum time, are we? We moved away from scratching so fast there. And there again. Okay, let's fix that. Let's see. So in stop time. I feel like this logic is not working. So we weren't moving because we were scratching. If the length is less than or equal to 2, which it is for scratching, it's equal to 2. Updated now. Is logic wrong? Big min stop time. This is 2, which is in seconds, so we stopping for a full 2 seconds. No, not last stop time though. This should be state. Last state change time. Let's get a look at some values when this actually happens. Yeah, so we're actually going to need some more stuff in here to break some of this up. Maybe we could go else print need to stay still longer. Print changing to a moving state. Yeah, here at the beginning, we're basically just missing our roll, right? Our roll is like 1 in 30 or something, 1 in 10 maybe. Okay, so I feel like we just... But we can't really tell when it started. Okay, let's go also... here. Print. Hit right wall. Scratching. Hit left wall. Bottom wall. Hit top wall. This is where you do keep hitting like move up or left or up left. We kept running into the same two walls over and over again. We had some logic to select an opposite wall, like one that we weren't touching, then it wouldn't do that, but see, there. Okay, so we hit the top wall. Stop this. We hit the top wall and we moved on so fast. So what happened? We hit the top wall. We changed to a moving state. Hit the left wall. And here it looks like we did wait enough time. Did I miss it? The left wall. Hit the okay, yeah, right here. It's the previous one. So we actually hit the top wall. Then we started moving again and hit the left wall. Then we waited for a long enough time. We started moving again and we hit the top wall again. But this top wall here is what I'm interested in. We changed to a moving state. We hit the top wall. These are the same. Did I just mess up my prints? Are these always the same? Yeah, it looks like I messed up the print. These are always printing the same thing. Hmm. So I didn't mess up the print. Doesn't look like. But now and last. Things are always the same. Why would that be? So last state change time should stay the same from frame to frame, and now should of course get bigger from frame to frame. But that's not actually happening. Last state change time is always incrementing with now. And we never got this need to stay still longer. That's the other thing. We never saw that getting printed. So let's look at state Well, yeah, we're not. Oh, I put this in the getter, not the setter. Yeah. So every time we accessed current state, we were updating the last state change time. But we only want to change the last state change time when we change the current state, not when we get the current state. Okay. Oh, okay. So now we have the next problem, which is that we always need to stay still longer. We never get out of the sitting. Okay. We need to work on this logic, basically. I think because our last state change time starts on -1, -1 plus the minimum stop time is never going to be greater than now. We need to fix that logic, but I'm going to have to step away for just a moment, run to the restroom, and then I'll be right back. Okay, and we're back. So I think we can just flip this logic around and it will still work how I am wanting it to, but it will not get stuck at the beginning because of the -1. So instead of checking if now is less than that, what we could do is say basically opposite. If well, I just have it backwards too? Does it just need to be greater than? So in the first iteration, this would be -1, this would be 2, so it'd be 1. So if now is greater than 1, then we're allowed to do it. Then it would get updated to something like this. Would add 2 to it. Yeah, maybe I just had it backwards actually. Hmm. Well, we almost made it to the wall, but not quite. There we go. There's our 1 pixel away. Inch to scratching top. Sleeping. I think it chose to move to the right again. Made it then start scratching in extra time. Looks like it's done that a few times now. We stuck? Oh, nope, we finally made it. So I'm debating kind of whether I want to make it harder for it to get stuck scratching over and over again, or if it's okay that it just gets stuck scratching over and over again. I almost think... I mean, cats have a mind of their own. Cats are gonna do what they want to do. I almost kind of like thematically that it can just choose on its own to do something for longer than need to maybe try to strike a balance between printing so much and printing at the right times. Would like to understand more like when it's choosing what direction it's choosing to go and stuff like that, and how many times it's choosing to go back in a direction that it's already at the wall for. But the spam makes it a little hard. It prints so much that it makes it a little hard to actually keep up with where it's at or what it's doing. I think what's happening is when it does those extra long scratches, it's basically choosing to start moving again, but then choosing to move in the direction of the wall that it's already next to. And that's sending it right back into scratching. So we could add logic that makes it, when it chooses to start moving, it tries to go in a direction other than the one nearest wall. But again, I think I actually kind of like the idea that it sort of does its own thing. I mean, it's kind of how cats are. Cat wants to sit at the wall and scratch for an extra long time. It's gonna do that, really, whether or not you want it to. That kind of adds a little bit of charm. I feel like here, spent quite a long time scratching the bottom wall, and then when we finally did change, we just started scratching the right wall instead. We've been going at that for a while, back to the bottom a little bit. And the thing is, it can choose any one of 3 directions. 3 out of the 8 possible directions results in it still just scratching again. Because moving down and left, moving down straight, and moving down and right, all 3 of those would result in it scratching again if it's at the bottom wall already. So really the question is, do we value higher variance more? So if it is at the bottom wall, we want it to definitely walk away from the bottom wall to make it varied more greatly? Or do we value kind of the charm of the cat just having a mind of its own, right? Choosing to stay there for extra long just because it feels like it. I think I fall on the latter, especially being a cat parent, if you will. Cats very much have a mind of their own and are gonna do whatever they're gonna do, so like virtual cat pet probably should be kind of the same. I definitely like the 1 pixel away from the edge change. That was a change we made recently, and I think I've seen it on all 4 edges now, and I think I like the placement of it, and I like that it's consistently always scratching the same same place. Whereas before it was like sometimes it was closer, sometimes it was farther away. One thing I have noticed, this seems especially apparent when it's on the top or the bottom, but if it, I'm guessing what happens is like if it's on the bottom and it chooses to go down and right, or down and left, I should say, it's taking that step to the left. But I think it happens so fast that it kind of looks like it's staying in the scratching animation and just moving to the left. Let's see if it happens. No, we went to the right. You know, one thing we could do, well, that would throw off. It would throw off the tile width. I was gonna say we could, or like right there, it just took a small step to the left. I think it just did it again. But I think it's, and then it just went back to the right. I think it's choosing to go down and left or down and right. And it's actually ending up taking that side step, but not down step. Because the way the logic is for moving, just gets to here. It checks if it's allowed to move left or right. In this case it is, so it goes ahead and takes that step to the left. And then it checks if it's allowed to move up and down. In this case it's not, so it knows that it ran into the bottom wall. But we already took that half step to the left there. I think I'm okay with it too, though. I've noticed it. And it does happen so fast, it kind of looks like it stays in the scratch sprite instead of changing to like the walking sprite, but it will also sometimes like keep scratching but reposition itself. We go straight from yawning to sleeping. I think we should stop to sitting first. Yeah. I think here we should go 2 frames of sitting. We could start further away from the corner, maybe? And we wouldn't be so likely to scratch either the top or left walls right at the beginning. There's our sleeping, yawn, yawn, sit, then sleep. Yeah, I like that better. I think maybe it should be slightly more likely to stop. Well, now it's doing it. Stop and sleep or clean. I think our stop chance factor should be a little bit smaller. That way it's more likely to actually stop before it hits the wall. Let's make sure it doesn't do it too much now, because we do still want to be able to hit the wall fairly frequently. That small left step. I almost wonder if it's too high of a chance now. Maybe 30 was the sweet spot, because now it doesn't... feels so much less likely. It's anecdotal too, right? It's random, and we've only let it run for a few seconds, so... even a full minute yet, I don't think, but... it feels like it's just way less likely now to actually hit the wall. Like it's almost guaranteed to stop after only a quarter of the screen or so. Let's put that back to 30. I think I liked the feel of it before. Should we start in a random location? Or start in the center? I think we'll start in the center. I don't need this anymore. I don't need this anymore. This anymore. Go animation. This should be called something different, I think. Sprite. So we're creating Neko animated sprite. Before we add it to the main group, let's just go Neko.x equals display.width over 2 minus Neko.tile width over 2. Should make it start in the center. Yeah. Went straight to the top that time. Sleep. Stopped to clean before we got to the bottom. Other direction. Yeah, I think I'm liking the feel of the randomness. I think what I'll do now is back out for now. I think basically we need to go through and clean up the code some. And I guess decide if we want a separate file for this. Or if we want to keep it all in one file. I mean, it's that much code, 200 lines, I guess. Some of this, though, we're not going to need, right? This can cut out. Some of the prints we could do without. All right, that got us down to 225. Still have all of this, which we don't need. This was like brainstorming. I think we've implemented this by now. I think for now I'm just going to keep it all in one file. Eventually, we could generalize this class into some sort of like overrideable animated sprite, and then we could basically get all of the animation related functionality into that class, and you could use it for other things, and you would always just override and make your own logic for like update. This is where all of my cat logic is at. More generally, you could use the animation portion of this class for other things, inside of a game or CircuitPython app. And at that point, once we did make a more general, like just animated sprite, then it would be in a different class by itself. But it probably would exist in a library or something somewhere as well, so I'm leaning towards just leave everything together for now. 109 lines. It's on the longer side ordinarily, like for basic code for learning guides and stuff. I would aim for a little shorter than this probably if I could manage it. Not like super long, but certainly wouldn't want to go too much longer. So I'm just gonna clean this up / get it ready for being actually used by people out in the world. So one thing is I'm going to put background color at the top, because that's meant to be like a configurable thing, right? If you wanted, pink or whatever, you could always just change this up. Now we got Neko cat on pink instead of blue. This is kind of like a configuration, right? The user could edit this to whatever color they want. Same kind of things with these. Like, these are configuration. The user can play with these values if they want. I mean, I picked numbers that I think work pretty good. So if you want to just use the same numbers and let it run, throw it on your desk or whatever, I think that's fine. But if you did want to tweak the behavior a bit, you could play with some of these. Like, if this was 20, then the cat would be taking bigger steps, which would make it seem faster. Back to a moving state here. I love the little tail waggle while it's scratching. Yeah, so we're taking bigger steps each time, which makes it seem like we're moving a little faster. But I think 10 looks pretty good. These ones are the chances that it will stop and sleep or clean. For the first one, chances that it will start moving again after scratching. So we're just going to start commenting, cleaning up as we go here. This is mad because it wants 2 lines. How lower number is more likely. Stop time. So this is the minimum. Really, this should be called like minimum scratch time. Honestly, we really only use this when it's scratching, I think, right? Because it's not moving and the animation list is less than or equal to 2, which means the scratching state or the sitting state, but we're not actually using the sitting state really. So we must be scratching. So this, we could change it to be more specific. Let's call this config minimum scratch time. Minimum larger time will larger time means stretch for longer. But it is still random, right? It's also based on this. But this is like, you must wait this amount of time, and then your chance factor starts happening. So these are state index. State object indexes. Last time animation occurred, which basically means the last time we changed the visible sprite. Is this green? Hold it wrong. RED. Last move time. I think we use that anymore, do we? Yeah, only usage. So that was before. Now we're moving at the same time we're animating, so we don't need a last move time separately. Current animation index. This is index of the sprite currently showing. Index of the sprite within the current animation that is currently showing. In current a lot, but last state change time. Last time the cat changed states. Which is used really just to enforce this, right? Yeah. Used to enforce minimum scratch time. Okay. Now these are all state objects. State objects which follow this pattern. They're tuples. They have an ID. They have an animation list. They have a step sizes. Animation list is also a tuple. I'm going to put it in parentheses. Step sizes is also a tuple, so I'm going to put it in parentheses as well. 1 second, I'm going to move the sun blocker real quick. Finally got the sun back out on us. I'm going to put an extra empty line between sitting just to draw some separation between sitting. These are all moving. These are all scratching. And these are the two others non-moving ones, cleaning and sleeping. These states count as non-moving. Actually, do we use this? No, we don't use this. We just always check moving states. We don't actually need this. Because then when we chose a random one, we did specifically cleaning and sleeping by themselves. We left out sitting. We put sitting back. Choose a random one for sitting. I mean, when you clean and sleep, it involves a little bit of sitting. Yeah, I think I like it how it is now. We don't really need this. Private. This one's a private field, but we have a property to access it externally. Current animation list. That's a list of sprites. It. sure the right way to do the syntax here. Does the docstring comment come inside of a init? Trying to find an example. Really matter too much what it is, I don't think. Be helpful if it had a docstring though. Okay, comes before. Inside a class or init. And let go. Neko animated cat Sprite. And basically a description of what it does, which is going to be and then these are like param, like this. Okay. Param, type, name, colon. Param. Float. Time, colon. This is how long to wait in between animation frames in seconds. Unit is seconds. We don't use I don't think we use movement time anymore, actually. Save this to make sure it doesn't crash. Nope. Window. Weird. Yeah, didn't crash. Were we passing that when we initialized it? No, we're just doing defaults. I guess we could also throw on here maybe default is 0.3 seconds. display size, param. Need that? No, I don't think we do. Param display size. This is a tuple. Display size. Tuple containing width and height of display. Defaults to values from board display. If you're not using a built-in display, you would need to pass this in. But if you are using a built-in display, then it will just take the ones off of board. Those are our only two params. Save that. If display size was not passed, try to use defaults from board. I don't know if we actually need those. If there's not, let's go. Have to pass display size if not using dim display. Which we would never see this on a PyPortal, but go ahead and do it just in case if folks are hooking up a separate screen and they need to send this in. I guess up here we should say also defaults to values from board.display used to determine when we are at the edge, so we know to start scratching. Inside of here, use the display size passed. Load the sprite sheet, which is going to load a bitmap. Neko cat sprite sheet, that seems fine. We want to make the first color transparent, which in our case is the blue, and then we did actually go ahead and add the blue back, but as you saw before, we set it to pink and it still worked, so that's why we would need this in case if someone changes to a different color. Create a sprite, tile grid as self. I think we want these here. Yeah, actually, I think it just should just say load the sprite sheet bitmap, no parentheses, bitmap and palette. First color transparent. Create a sprite tile grid as self. We're extending tile grid. Animation time. Okay. So now this, why is this mad? It wants one or two? Too many blank lines, it wants one. Okay. So this is a function, oh, we didn't do return. Well, I guess return here would be do that automatically. Does it's advanced, so I mean this does return none. Advanced animation index. It will help our function to increment the animation index and wrap it back around to 0 after it reaches the final animation in the list. Okay, animation time property. This returns the animation time. Basically the same as this, right? In between is not a word. How long to wait in between animation frames? Unit is seconds. I think the way it works is we leave the setter blank, right? Doesn't it know to pick up the same doc string as the getter? Oh. And this returns none? No, this returns the current state. Current state object. I'm also going to go ahead and put this little key here. This can be tuple too. States are technically a tuple. If it wants this, we'll run black, of course. It will, if it wants. We're doing a couple things here. We might as well throw in a few comments. So update the current state object. Update the current animation list. Set current animation index to 0. I'm going to say reset. Show the first sprite in the animation. Date the last state change time. Animate returns a Boolean. So this will, if enough time has passed since the previous animation, then execute the next animation step by changing the currently visible sprite and advancing the animation index. So this should say actually true if an animation frame occurred, false if it's not time yet. Animation frame. I think these are be indented by 1 if they're a continuation, but I'm not sure. Is time to animate, or let's say it is time to take an animation step. Maybe time to do an animation step. Actually, let's go out here. Is it time to do an animation step? Update the visible sprite. Advance the animation index. Update the last animation time. No, not time for animation. Okay, it's moving. This returns Boolean true if cat is in a moving state, false otherwise. Update turns nothing. So this will attempt to animate, to do animation step. Attempt to do animation step, move if in a moving state. Check if in a moving state, change states if it is time to. Change states if needed. So we could obviously get a lot more verbose, but I do want to keep it fairly simple, just high level. What does this do when you call it? It attempts to do the animation step, it moves if it's in a moving state, and it change states if needs to. Doesn't return anything. Attempt animation. If we did do an animation step, cat is in a moving state. Random chance to start sleeping or cleaning. Change to state sleeping or cleaning. Else, this is else. Cat is not moving. Moving really means like walking, I guess. Like cleaning kind of is moving, but not in the context of this. This is a tricky line to comment. If we are sleeping or cleaning or another complex animation state. Right now there's only two, but maybe we would have, maybe there would be a chance to add another one. That's why I wrote the logic this way. It was in case we did add more, the logic would keep working. But this is actually opposite. If we are, this is actually if we are scratching. This should actually here. Scratching state. We've scratched the minimum time. Random chance to start moving. Start moving in a random direction. For sleeping or cleaning or another complex animation state. If we have done every step of the animation, then change to a random moving state. Okay. If we are far enough away from side walls to take a step in the current direction, move the cat horizontally. Okay, current state, step size. Let's call it step size X, and then the other one will say step size Y. Ran into a side wall. Ran into the right wall specifically. Change state to scratching right. Change state to scratching left. We're far enough away from the top and bottom walls. We take a step in the current moving direction. Move the cat vertically by current state step size y. Top and bottom wall, we ran into the bottom wall. Change state to scratching bottom. Scratching down, I guess we called it. Change state to scratching up. Default to built-in display. Create displayio group. Set up, say create background group. Add background to main group. Create Neko. Put Neko in center of display. Add Neko to main group. Show group on the display. And main loop. Update Neko to animations and movements. So we ended up at 300 lines after I put comments. Again, is kind of a lot, but not terrible. You know, again, I don't think we would want to go too much bigger, right? We're up in the 1,000 lines of code line. That's probably too much for a learn guide. Something probably needs to be refactored or moved into a library or something like that. 300 is getting close to too big, but probably not quite there. So I'm gonna save this. I am gonna, so I guess as a look behind the curtain for folks that maybe haven't done any learn guides, so ultimately what we're working on here will be in a learn guide. We've now written the code for the project. The next thing we need to do is basically put it in the learn guide repo. So let's go do that. Open learning system guides. Let's go new window. And git fetch Adafruit. Git checkout -b ecocat from Adafruit main no track. Now we're on a new branch that started from Adafruit main. Do I want to call this PyPortal NekoCat or just maybe CircuitPython NekoCat? Yeah, I think CircuitPython NekoCat. Because you could run this on other things. PyPortal is what I'm using. PyPortal is nice because it's an all-in-one thing. Built-in display, but as long as your display is big enough that a 32 by 32 sprite actually has room to move around, then you could use this on your device. So let's call it CircuitPython NekoCat. We're gonna go new folder, CircuitPython. Maybe we'll just call it Neko. Python Neko? Neko cat. Go software. It's the Japanese word for cat. Neko. I want Neko cat. Even though that's like cat in two different languages. We're gonna make a code.py. Yes, we want to add it. This is the code we've been working on. Save that. We need to paste in the bitmap, Neko sprite sheet. Copy. How did that close? I'm not sure. Neko cat sprite sheet, there it is. Yeah, I mean, if we wanted to make this a little more efficient, we did not end up using any of the footsteps. So theoretically, we could cut out, I mean, honestly, we could cut out everything below, everything in the last two rows. Save memory, because technically this is getting loaded into memory. If we wanted to get fancier, we could try to figure out how to use the footsteps. But I don't know, like, where would it go behind the cat or in front of the cat? I don't know. Really come up with a good way to use the footsteps. Could put the mouse on the screen. We talked about also the red dot for the laser pointer yesterday, which I do kind of like the idea of still. But I also kind of want to get the basic one done and up and get feedback on it from Lady Ada or whoever is interested. Lady Ada is where the idea for this came from. Because if there's like stuff that we should change about the way it animates, it would be good to do that before we really like go for like kind of extra credit type stuff like the laser pointer dot, or the touchscreen interaction or anything like that. Does it need anything else? I think the bitmap, the CodePy file, I mean, it needs libraries, like, well, it needs the image load library, I guess, which is it. Need anything besides that, though? No fonts, because there's no text. Needs anything else? You know, is technically make animation time a variable up here and then pass it in. Like right now, if somebody wanted to change the animation time, they would either have to scroll all the way down to here, change the default, or more correctly, what they would do is actually scroll all the way down to here, where Neko gets created, change it right here if they wanted to change the animation time. Gave them a variable up here, though. They could just change it right at the top there, which might be nice. I think I like that. We'll pass that through. That way they can update this at the top, and then it'll take effect. So copy this back to the device and make sure, well, I'm editing it on the device actually. Okay, so I'll copy it into Learn Guide code. Sure, it actually works here. So right now it should be doing the same thing, still 0.3, but if I change it to faster, yeah. Yawning is so fast. So fast. I think 3 times a second is pretty good. Second. This feels. If that was on the PyPortal itself, or is that just in the video stream? It kind of jumped a big chunk there. Could have been just the video picking it up though, or it could have been on the PyPortal. Maybe it garbage collected or something. I guess it's just a hitch in the video though. Yeah, that's a little too fast. I think we got it on the nose the first time, 0.3, but we'll leave it as a variable up here. That way folks could play with it if they want. You know, they can make the super fast cat if they want to see it. They could slow it down even further if they wanted. I like a couple of my learn guides. I kind of like this idea of trying to make the code do sort of one thing by default, but have a couple of values that are really, really super simple, easy to change right at the top of the file. That way folks can, like, when they're running the project on their device, they can, you know, start to tweak things to make it do stuff. I think it's really powerful for folks that are learning to code if they can, like, tweak a little bit of the code and see the result happen, right? Being able to change a background color, you know, to pink or whatever you want. Doesn't seem like that big of a thing, but if you're just learning to program, like, it's relatively complex and it's a nice, like, step to be able to make a change and actually see it happen. And by giving them a nice easy variable at the top here, it makes it more likely that they find it, makes it more likely that they change it and don't break anything. I try to provide some sort of like settings type things at the top there usually where folks can tweak a little bit to observe how it works and just get that little thrill of actually being able to modify it and have it do something differently than it was before. So that does work. We changed the speed, everything was good there. Did this lose a new line up here? No. Okay. So let's go, we pasted our code in now. Let's go, oh, you know what we're gonna need is a license. I have no idea what the license for this is. Neko cat writesheet.bmp.license. This came from here? I closed it. This public domain on the Sprite. Sprite sheet. This is where I got the Sprite sheet from. That's public domain here, but not much else in the way of license information. Pretty sure it just came as a file, yeah, an image file, not like a zip. Alright, let's get this out of here. Close this. Legal. By use of this way. Their agreement. Oh, there's a bunch of these things. Huh. Give me cake. Interesting. Credit. Use give credit to Nintendo. So, it, you know, it's not like necessarily an official license, but they at least put a little bit of license information with it. And really the only thing I can find is this mentions public domain in the Sprite sheet itself, so really all we have to go off of. I guess there's maybe not reuse enforcement on some of that stuff. Think of somewhere where I've used a public domain. Since before, so I could go and snag the right lines. Let's use public domain vectors. Copyright and CCO. But we don't have a copyright year. We could put Good Clover as the person, I guess. And then just public domain. Like a license. Forget how. There's no licenses here. Matter as much. Know the year, so I'm just gonna leave the year blank, and I'm gonna put this name here. Good Clover. Thank you, Good Clover. Work domain. And one. Maybe I should try to run this on my other PyPortal. Doesn't have any of the files. I don't think there's any other files. I'm taking a quick look through here. The Sprite sheet is the only thing it has to load. The background comes from hex color. It'd just be the one thing. So I think the CodePy and the BMP is really all it needs. So let's go and run inside of here. Ooh, too many. Okay, CircuitPython Neko cat. And here, let's go pilot RC file is up dot RC file dot pilot RC. There we go. And we want to run that on CodePy. That's weird. Line too long. Bunch of lines too long. I should try to figure out how to get this number to be enforced by this line. I have this line in my editor. But I think it's a different setting. I guess we'll do this. Why does it feel like this? Why that jumped? It really didn't save any space. Guessing we're still too long on 64. We didn't save. Yeah. Sometimes, like the changes that Pylint makes, end up causing the code to be less readable. I mean, it's not like this is that readable anyway, I guess, unless you already know what it does, but like, I feel like previously I was able to glance at it, tell what was going on better, and now there's a random new line, and it's not nearly as easy to tell, like, just at a quick glance which value is what, but which is how we must use the Pylint. So 246. If we're far enough away from the sidewalls to take a step in the current moving direction. A little more concise there. I have the same problem here though. Like this here as well. Like we can split this. But honestly, I feel like at a glance it's harder to tell what it's doing now because the value is not really in the middle. Two outer values. I mean, it is still logically, but trailing white space. Okay. Oh, that one's not going to be enough, is it? This is longer, huh? Top and bottom walls. Far enough away from the top and bottom walls. Step in the current moving direction. Maybe the next one. Go to too many branches. Probably just living with. Import time should be before board. Too many branches. Go to. Side of update. I mean, I guess the way we get fewer branches in here is refactor this to more named functions, like all of this stuff lived inside of its own function called, you know, top scratching or something. I don't know. I don't necessarily think I want to refactor it just to please Pylon though, because I think it changes the chronological. Like if we want to move this into a function, we have to declare it like up here, you know, and it or down below, one or the other. But it makes it so that the code that actually executes here is somewhere else in the file. Where I think we have a good balance right now of like, there's a lot of stuff happening inside of this update function, but it all flows chronologically, right? I don't necessarily want the user to be like, oh, we ran into the sidewall, so then let me scroll up here and figure out, you know, what happens when we hit the sidewall. Then scroll back down here and figure out what happens next after we do the sidewall thing. And just, you'd have to bounce back and forth a lot. I don't think, in this case, the clarity we gain from refactoring to have one fewer branches, or less, I guess we could refactor more out. But I don't think the clarity we gain there is worth the amount of jumping that folks would have to do. And this is not meant to be a library at this point anyway. This is meant to be a project, so I feel like I'm okay with the branches, honestly. This? No meeting, yeah. Python typing. Oh, typing in. It's 710 right now, is that right? 711 right now. Missed a release. Alright, so I think I'm probably gonna head out here pretty soon. Ordinarily, today's Monday, there would be a meeting, but the meeting is put off till tomorrow because of the holiday in the US today. See, I will finish this up, which was Pylint. Yeah, I think we're just gonna go with the old Pylint allow. No. If that's the right syntax. Yep. Still got the error. Can I not up down in this? Type in this at all? Did I do the Control S thing again? Sometimes I push Control S when my focus is in here and it makes this get stuck. I don't know what Control S actually does in a terminal, but it's not good. S for stuck. What does the Pylint disable? Memorized how to do this right. Pylint : disable equals. We're close. Oops. There we are. Okay. Alright, I'm gonna be right back again. I'm gonna run to the restroom and then I'm just gonna wrap this up. I'm only gonna be running for another few minutes anyway, so I'll wrap this up and then head out for now. Okay. So we ran Pylint. We're gonna do black code formatting. This. Black, so let's go black T pi35 CodePy formatted. Longer. Yeah, black formatting. You know, I probably should have ran black formatting before. See, stuff like this, I just don't. I mean, I get wanting to keep the lines from being too long, but I don't know. This is less readable, not more readable to me. Doesn't matter though, right? We gotta run the black, otherwise it's gonna fail the CI and just not be merged. So, oh, and this, like, I don't. Yeah. I really don't like that. I mean, can it really not just be? Not be this or something? It's such a small thing, but I really hate that. I think that looks awful. To see if there's any way we can avoid one per line. It's waste. Right. You know, I guess we'll keep it. Does it? That's a bummer. So. These ones look better, I will say, than they did before. They're easier to understand now being on different lines, so I like that. Right. We got our pilot and our black. I would, if I had a way to make this not happen, I would, but like black's gonna do it no matter what, so we gotta leave it. And we passed black and pilot. We have all our files, so I'm gonna go commit. Push. Call me guy. Neko cat. That's the branch we want. Thing I'll do as well maybe is record a quick video of it. Oh, come on. This and it will. Our three changes are CodePy inside Neko, Sprite sheet in license. That seems good. Create this. And there we go. As long as this passes the CI checks, we will request a review. I think Anne's doing the Learn Guide reviews these days. Most of the time, I mean, I think Limor does some too, but I think Anne's mostly the first wave. All right, so yep, I gotta wait on this to see if it's gonna pass, and then I'll request a review. But that gets us to where we were going for now. So I'm gonna head out for now. Again, normally we'd be getting ready for the meeting, which would be coming up here in about 20 minutes, but it is 1 day later than normal this week, so the meeting's not until tomorrow. But I am still gonna head out and go and eat some lunch and do some other things. I'll probably be back this afternoon working on some PRs potentially and some other things. I don't know if I'll stream. Probably won't stream. But yeah, I'll be around and be working. So if folks are interested, of course, you could always hang out in the Discord with us. Yeah, and so I'll be back on Saturday for sure. Will be the next time I'm back. Saturday morning, 10 a.m. Central Time. That's my normal stream time, so I'll definitely be back then. And then I probably will also be streaming next Monday. That's after Saturday, of course, but I'll probably be streaming again next Monday around the same time I did today. But I don't know for certain. Saturdays are my actual like designated stream days. Mondays I am working on CircuitPython. I may or may not stream during the mornings. It probably just depends on what I'm working on, if I think it makes sense to stream it, or if I want to stream it to get it out there to be able to refer back to it later. I can already tell this fell This failed a pilot check, so I'll have to figure out why that failed here and not locally. 271. So this ran on Python 3.10, but it ran pylint 271. A quick look at this before I head out. Let's go pylint version. Oh. Not have a say the version in the help either. Brilliant. Pylint version. Guess I could do it with pip. Pip show. Pip show pylint 271. All right. Well, I guess that's due to the difference in the version of Python. Seems a little weird to me. But this is using Python 3.10.1, whereas I'm using Python 3.8.10. I would have thought the version of Pylint would be more important than the version of Python for raising these errors. It's weird too. This give me a 10 out of 10. Huh. So I'll have to figure out why this is different than when I ran it locally. Either my command must be different, or I did the RC file wrong or something maybe. Or else the difference between Python, like I was mentioning just a moment ago, maybe has something to do with it. I'm not sure, but I will have to get that resolved. So that's another thing I will be doing probably a little while later today. But yeah, I'm going to head out for now. So thank you everyone who watched. Hope you found this interesting, and I will catch you next time.